Okay, so when you think about butterflies, you probably picture, sunny meadows, maybe some flowers, just gentle beauty, right?
That's the standard image.
But we're going to talk about the early days, before the butterfly.
Yeah.
And honestly, it's less ugly duckling and maybe more straight up monster movie sometimes.
It really is a totally different world, isn't it?
Yeah.
We fixate on that final beautiful adult form, the butterfly or moth.
Yeah.
But that caterpillar stage, scientists sometimes call them lured larvae. That's where the really radical biology happens. It's survival mode dialed up to 11.
Exactly. These aren't just cute, fuzzy things. We're talking cannibalism, shape-shifting, poison, serious stuff.
And if we connect this to the bigger picture, they really are the stars of that whole metamorphosis cycle in many ways. They're survival machines.
Yeah.
Assassins, even.
Right. They deserve the spotlight. So that's kind of our mission for this deep dive, exploring how these creatures actually thrive out there using these just astounding strategies.
And it really starts with one core thing. Eating. Constantly. You really can't overstate it. The caterpillar has, one job. Consume. Its whole body is built for it.
It's basically just a stomach with legs.
Pretty much. It's the Kirby of the bug world, just inhaling everything.
An unstoppable bulk phase. That's a good way to put it. They're not just nibbling. They are dedicated eating engines.
And what's fascinating is how specialized they often are. Almost all of them eat plants, right?
Yeah.
Specifically the leaves of their host plants.
The plant their mother laid the egg on?
Exactly.
Yeah.
So the plant is everything. It's the all-you-can-eat buffet in its home base, providing shelter while they grow.
And the scale of this growth, it's actually hard to wrap your head around. It's not slow and steady.
No way. It's explosive. Absolutely explosive. From the second they hatch, these tiny things just expand. Some sources say they can pack on up to, 10,000 times their original weight?
10,000 times. That's insane.
It really is. That astronomical jump in sheer biomass just shows you how focused that early life stage is. It's all about gathering energy, just this incredible concentrated bulk phase.
Okay, so that dedication to munching leaves is like their defining trait, which makes the exceptions, well, pretty shocking, actually, because not all caterpillars stick to the salad bar.
No. Some of them trade the leaves for meat?
Whoa, wait, what?
Yeah, this is where the story gets a bit slasher flick. You find a few species out there, these rogue caterpillars, that have become these incredibly efficient little assassins.
Okay, hold on. How does a creature basically designed to chew leaves suddenly become a hunter, a predator?
Well, you look at places with unique evolution, like the Hawaiian Islands. Perfect example.
Right.
There you find the Eupithecia caterpillar. It's a type of inchworm. But this inchworm, it dits the leaves. It eats fruit flies, spiders, crickets.
Seriously?
And get this, even other caterpillars.
Yeah.
Documented cases. Caterpillar on caterpillar violence.
That's brutal. How does an inchworm even catch a fly? They're so slow.
See, that's the genius part. They're masters of ambush. These little guys, maybe an inch long, hang from their back legs. They look exactly like a twig or part of a fern, just perfectly still.
Okay, camouflage. Makes sense.
But the trigger is in sight. Their bodies are lined with these ultra-sensitive bristles, like tiny tripwires. The moment some unlucky bug, a fly, a small spider just brushes past.
Snap!
Exactly. They lash out with these spiky front legs, incredibly fast. They anchor themselves and just snatch the prey. It's over in a fraction of a second.
Wow. So why there? Why Hawaii?
Well, the thinking is it's linked to Hawaii's unique ecology. Something like 90% of the native land species there are endemic, found nowhere else.
Right.
And crucially, the islands lacked many common insect predators you'd find elsewhere, like, say, the praying mantis. So there was this abundance of prey just available, an open niche.
So the inchworm basically saw an opportunity and went for it. Forget the leaves, there's easier protein over here.
Pretty much. Yeah. Incredible adaptation. But okay, even the vegetarians, the luth eaters, they've developed defenses that are just as mind-blowing.
Yeah, if you're not hunting, you better be good at not being hunted.
Exactly.
Yeah.
So let's talk about goo. You mentioned gooey. Meet the jewel caterpillar, Dulceridae.
Oh, I've seen pictures. They look unreal. Like little jewel-toned jelly beans wobbling along, or wiggly gumdrops, sluggy body, no obvious legs, just gorgeous colors.
They look completely harmless, maybe even tasty, right?
Right?
But that's the trick. Their defense is brilliant, and it's twofold. First, those beautiful bumps. They're filled with this sticky, oozing goo.
Oh.
Yeah. Imagine taking a bite and getting a mouthful of that. It gums up the predator's mouth parts. It's an absolute nightmare for an ant or a bird. That's defense number one, the sticky trap.
Okay, pretty effective. What's number two?
Just as clever. If something does manage to grab hold of those gumdrop spines, they detach really easily.
Like a lizard's tail.
Exactly like that. Sacrifice a part to save the whole. The predator gets a sticky, non-nutritious blob, and the caterpillar escapes. Pretty smart.
Okay, so goo is one way. What else? Sometimes it's just about warning signs, right? Bright colors.
Mm-hmm. Moving from sticky deterrents to just shouting, danger with color.
Oh.
Which brings us to the famous saddleback caterpillar.
Ah, yes, the little guy with the saddle. Found across the eastern U.S., bright lime green. You really can't miss it.
And that's the point. That bright color is a classic warning signal. It's called aposematism, basically yelling, I taste bad, or I'm dangerous.
And in the saddleback's case, it's definitely dangerous.
Oh, yeah. It backs up the warning. See those horns, those protrusions? Every single one is lined with these tiny, hollow hairs filled with venom.
Ouch. This is just brushing against it.
Instant pain. Serious pain, swelling, sometimes even nausea. Any bird or predator that ignores that neon green warning sign is going to regret it. Big time.
Okay, wait. I remember reading something else about this one. It has a trick, right? A bluff.
It does. This is next level defense. If the bright colors in the venom weren't enough, get this. It has a built-in fake face. Markings that look like eyes and a mouth.
But they face backwards.
Yeah, exactly. It's positioned on its rear end. So a predator, maybe a bird attacking quickly, might strike the wrong end.
Ha! That's brilliant.
It totally confuses them. It either makes them waste that critical first strike, or even better, tricks them into biting the part of the body that's most heavily armed with those venomous spines. Strategic genius.
That is just, wow. Okay. But sometimes the deadliest things aren't the flashiest, are they? Sometimes they're the ones you just don't see coming.
Precisely. Which leads us to one of the most genuinely dangerous caterpillars out there, the giant silkworm caterpillar, Lenomia obliqua.
This one's found down in Brazil, right, in the rainforests, and it's cryptic, meaning it blends in really well.
Extremely well, and that's part of the danger. Its sting isn't just painful. It can be potent enough to kill humans. There are documented fatalities.
Seriously? From a caterpillar sting?
Yes. And the official numbers, like maybe 5 reported deaths between 2007 and 2017, are likely underestimates because of where they live, deep in the rainforest.
And what makes them so particularly hazardous? Is it just super potent venom?
The venom is nasty, yes, but it's also their behavior. They don't live alone. They congregate in large groups, sometimes dozens or hundreds, covering patches of tree bark.
Oh, I see.
And they blend in perfectly with the bark. So fatal encounters often happen when someone, maybe leaning against a tree while working or hiking, doesn't see them. They put their hand or their back right onto a whole group of them.
Ugh, multiple stings at once.
Exactly. And reports suggest it's becoming more common as, farming extends into their habitat. Something like 400 stings reported each year, maybe 20 classed as severe. The venom gets injected through those hollow bristles, tiny sacs breaking on contact, straight into the bloodstream.
Okay, so what does the venom do? You said it's potentially lethal.
Yeah, here's where it gets really interesting and kind of terrifying. The venom is packed with powerful blood thinners, anticoagulants.
Blood thinners.
Yes. When it gets into your system, it throws your body's entire clotting mechanism into chaos. It basically stops your blood from clotting properly.
So bleeding.
Widespread internal bleeding. Without prompt medical treatment, like an antivenom, it can be deadly. All from brushing against what looks like a fuzzy twig.
That's horrifying. But there's a twist here, isn't there?
There is. A fascinating one. This incredibly dangerous weapon, this potent anticoagulant designed to cause havoc.
Yeah.
It's now being seriously studied for medical use. That exact blood-thinning property is being looked at by researchers.
To help people.
Exactly. As a potential source for new anti-clotting drugs. To help patients who suffer from dangerous blood clots, like in stroke or heart attack risk.
Wow. So turning this rainforest killer into potentially a medical thriller, a lifesaver.
It's incredible, isn't it? How nature's most potent weapons can sometimes hold the key to healing. Utility in the most surprising places.
Absolutely amazing. Okay, so if you can't poison your attacker and you can't rely on goo, maybe you just try to scare the daylights out of them.
Psychological warfare. Which brings us to the spice bush swallowtail caterpillar.
The ultimate imposter.
Totally. This little guy is a master of mimicry. When it feels threatened, it does something amazing. It changes its appearance.
It puffs up its front end, right? And it has these markings.
Markings that look exactly like the eyes of a small snake. And the shape, the way it holds itself, it looks convincingly like a little green snake head ready to strike.
Doesn't it even have an organ that it can, like, stick out to look like a snake's tongue?
It does. It's called the osmeterium. It flicks it out, this forked orange thing, completes the illusion. It's incredible.
So who's the target audience for this little performance?
Mostly birds. Birds are its main predators. So imagine you're a bird looking for a juicy caterpillar snack.
And you see what looks like a snake staring back at you.
You're probably going to think twice, right? You're going to hesitate, maybe fly off to find something less alarming. It's the insect version of a scarecrow.
Gives the caterpillar that split second it needs to survive. Genius.
Pure genius.
It's just, it really changes how you see caterpillars, doesn't it? They're not just these passive little eating machines waiting to become butterflies.
Not at all.
They're engaged in this constant high-stakes battle for survival, using everything from, chemical weapons and goo traps to elaborate bluffs and mimicry. It's intense.
Absolutely. Fierce, complex, fascinating creatures, and, utterly crucial to the ecosystem long before they ever get wings. The butterfly might get all the admiration for being beautiful,
Yeah.
but it owes its entire existence to this incredibly tough, weird, and wonderful larval stage. Maybe the real lesson of the ugly duckling isn't just about waiting for beauty.
What is it then?
Maybe it's about appreciating the strange, the resilient, the frankly kind of hardcore phase that makes the final transformation even possible. These wiggly little guys are the true survivalists.
That definitely gives you a whole new perspective next time you see one munching on a leaf. You're not just seeing lunch for a bird. You're seeing a master of defense, maybe even a potential killer or cure.
Exactly. And think about this next time you see one. Consider what's about to happen to it, that transformation.
Into a butterfly, yeah.
Inside that chrysalis, or pupa, the caterpillar doesn't just rearrange itself. It basically dissolves. It turns into this protein-rich goo.
Wait, what? Goo?
Yeah, as cellular soup, essentially. And then from that soup, the cells reorganize and rebuild into a completely different creature. The sheer biological radicalism of that, dissolving yourself and becoming something new. It's just astounding. Makes you think, doesn't it?
Yeah.